Section 7.1, Angles and their measure. An angle is formed by drawing two rays or half lines with a common vertex. We have the initial side, this first ray. We rotate through an angle alpha, the Greek letter alpha, and here's our terminal side, the second ray. When the rotation is counterclockwise, it's a positive angle. Here, our initial side, and then we rotate clockwise through the angle beta, that's the Greek letter beta. Here's our terminal side. So negative angles we go clockwise, positive angles we go counterclockwise. And then here, we start at our initial side, then we rotate through and we actually go more than a full revolution, so we'll talk about here shortly. We know that's more than 360 degrees. An angle is said to be in standard position if its vertex is at the origin of a rectangular coordinate system and its initial side coincides with the positive x-axis. Okay, so here's our initial side on the positive x-axis. We rotate through this angle theta, that's the Greek letter theta, and here's the terminal side. So since we rotated counterclockwise, we know that this is a positive angle. Here, our initial side, again, on the positive x-axis, that's our standard position, but now the rotation was counterclockwise through the angle theta, so this is a negative angle. So when an angle is said to be in standard position, it can either be a quadrantal angle or it can actually lie in a quadrant. So for instance, right here, here's our initial side. We rotate through the angle theta. Here's the terminal side, and we end up in quadrant 2. In this example, here's our initial side. We're going clockwise, so it's a negative angle through the angle theta, and we can see this ends in quadrant 4. The third one here, here's our initial side on the positive x-axis. We rotate counterclockwise here. So we know this is a positive angle theta, and here's the terminal side, and we can see it terminates on this the negative y-axis. So this is a quadrantal angle. So they either lie in a quadrant or they actually end up on one of the axes, which means they're a quadrantal angle. We are most familiar with measuring angles in degrees, but we may also measure angles in radians, and we'll talk about that here shortly. So we know that one revolution is 360 degrees. So we know that 1 degree then must be 1/360th of a revolution. Okay, so here's our initial side and our terminal side. They coincide with the positive x-axis. So we start here. We go counterclockwise in the positive direction, one full rotation, one revolution, and then we end up here at the same place we started. So that's a 360 degree angle, one full revolution. Here we start on the positive x-axis. We go through a quarter of a revolution. So a quarter, 1/4 times 360 degrees, that's our 90 degree angle, our terminal side here. So if we have our quarter revolution, 1/4 of 360 degrees gives us our 90 degrees. And then here, we've got our initial side on the positive x-axis. So we go through our rotation, our revolution here, and we do a half of a revolution. So we end up here on the negative x-axis as our terminal side. So we know that's a 180 degree angle. So half of a revolution, half of 360 degrees, gives us the 180 degree angle. So if we want to sketch some axes here, in standard position, we'd start at 0 degrees. And then if we were going in the positive direction, we'd have 90 degrees up here, 180 degrees on the negative x-axis. Go a quarter more, there's 270 degrees, 90 degrees more. And then we continue here, if we were going around again, to 360 degrees.